All right, in this section we're going to be looking at proofs in pre-calc, and the thing about this first example is that it's not going to have any trigonometry in it, but it'll show you what a proof should look like in these examples. So the main guideline, as you see right here, is to only work with one side of the equation at a time. Now, most of your math life you have done the same thing to both sides of the equation, but here you have to pick a side and then start from there. I generally pick the side that's more complicated, so we're going to start with this side. So we're going to start there and just do a series of algebra steps to eventually get to a result that looks like this. Doing one step at a time, first thing I see is, and the algebra is not super important here, but just one step at a time. So here I'm going to divide both of those by x, and so I can rewrite this as x squared minus x, and then I still have minus x minus 1 times x plus 1. So that's just one step because I only did one thing from that equation. Now I'm going to show another step, and I'm going to just put an equal sign right underneath the first one. I'm going to just create a column of steps right here. The next thing is I'm going to multiply these two together. I'm going to FOIL these two just like normal, and I'm just going to rewrite these as is. So if I FOIL this, what ends up happening is that I get x squared minus 1. Now I'm going to combine some like terms. Notice that I've got x squared, I've got minus x squared in here, so those are just going to cancel. This negative x is going to stay, but then I'm going to have negative distributed to a negative, so that's going to be a plus 1. So I'm just doing some basic algebra moves, and then the last step, though it should seem fairly obvious, it's not in a proof, is to show, okay, now I've got negative x plus 1. My goal is 1 minus x. So I'm just going to flip those around and do that as my last step. And that gets me to this side, which is the goal of a proof.